Okay, so I'm gonna do. So this is a real quick one, just because I couldn't hold myself, because I got other stuff to do tonight, and sadly I have to go and do other stuff. So I'm not gonna read the light paper yet. I haven't read this. Trust me. The only thing that I've heard is sort of the first hour of the launch space on X, where Liron does his like stupid intervention uh, and questions. I have absolutely not read any of these, but I think based on what I've heard that I kind of have a very very high level understanding for it. But I don't know. So what I'll do is I'll do another video tomorrow. Well, we'll read these and we'll double check. But I just wanted to at least kind of put out this like 10-minute video or whatever it will last to just to kind of drop um, my idea of what I think Extropic is building, at least the chip. And then we're going to see tomorrow. We're going to try to understand that from noob to like from just myself as a total noob. And this is not for the noobs as well out there, because there's a lot of people that just have, I guess, not the expertise like myself to understand like all the details, right? But it's one of those things where I think if you just kind of like try to explore from first principles, there's a lot you can understand. And at the end of the day, I think the magic is not in understanding what it is that it does, but like how it is that it does it, right? That's the alien part, I would say. Like be able to do this is probably crazy hard. And I guess we'll have to wait until the sort of more technical papers get published. But let's just okay. I'll stop talking. What I think this does. Okay, based on what I've heard Bev say and other people say on Twitter and on that first hour of the space that I heard. Essentially, what this is what I think this is doing is sort of, and I'm sure I'm gonna get it wrong. Okay, so just bear with me. This is I'm just probably gonna get it wrong at many levels, but we're gonna try to kind of peel this off then in the latest session. So what I think this is essentially the point of this chip is like it's just saying, look, like in classical in sort of the current hardware, you've got the chip that what essentially what it does is math mul, right? It just does math multiplication. So like if I don't even know if there's a way to JS Paint. I don't know if there's a way to paint this right, but like you essentially. Oh wait, I'm gonna go dark mode in Paint. So essentially, like, you know, what the current chip would do is like a neuron or whatever it is that you're doing, let's just focus on the neuron of a neural network, right? It's or a layer, right? Like whatever it is, but it's just a big matrix multiplication, right? So you have that big matrix that kind of represents your layer, and then you've got your input, right? And then you just do the multiplication, and then kind of off you go with the next step, right? So this encodes the biases, it encodes in a very neat way, like it encodes the weight and all this kind of stuff. But it's still a mathematical multiplication, like a matrix multiplication. That is what's slowing down the whole thing, right? So that's the bottleneck. How do you do this multiplication fast, right? And I guess it's just a bunch of tricks and whatnot. So, but essentially, what I think that, and I think this is the key difference, right? So, and let's not worry now about like, is this cheaper replacement for a neuron? Is this cheaper replacement for like an entire layer? Is this cheaper replacement for a program? Doesn't matter. Essentially, the difference is to use thermodynamics or energy or whatever nature, right? To let nature do this multiplication, right? In a way like similar to like all these like high school experiments where you kind of like see where, you know, doing certain natural processes like would find optimal shapes for things, right? So my guess here is that the how can I need to get used to dark mode somehow. So essentially what this would do is like, let's imagine for a second the chip is the neuron. I don't know if the chip is going to be something that, you know, you can parameterize and it's just multi-purpose, or you actually have to build certain, you have to build the chip for the chip for already sort of for certain applications. That doesn't really matter how it's done, right? But the chip is like, it's built in a way so that the when you power up the chip already sort of exhibits like a natural phenomena, like exhibits some sort of noise. This kind of noise function, or how you want to call it, in a way encodes that matrix. You know what I mean? Like it encodes something, right? And I don't know, maybe that's the better visual, right? I guess. And what do we have here? So whatever it is, right? But like it encodes, God, it encodes something, and it's a probability distribution. Whatever it doesn't matter. It encodes like something with noise or whatever it is. Doesn't matter. The thing is, it just encodes something, and then you can interact with this something to measure something else, right? So the point is, you don't do a matrix multiplication, but you're essentially, because a neural network, and I think that's one of the points that Liren was not understanding, at least that's what I thought, is like you have a neural network. At the end of the day, it's just like big function, right, that parameterizes a probability distribution. The only thing this means, because it sounds fancy, is that it means like if you imagine the output of a neural network, it looks like something like this, but in 3D or whatever it is your output dimensionality is, right? And essentially what defines those hills and valleys are the parameters and the hyperparameters and whatnot. And so when you give it an input to the inference, you're just you're just interacting with these. You're just running a bunch of multiplications that kind of give you the answer, and it's constrained by this landscape that the neural network kind of represents. So all what and it sounds stupid, like it's not that what Extropic is doing is simple. It's very cool actually, but what they're doing is like, it's just saying, wait a second, we don't have to. Why are we forcing ourselves to multiply? Whether we can just build a chip that already encodes that distribution in a way, right? So you only have to figure out a way to interact with these so that you can read something out of that, right? You can read the effect of that interaction, right? And this is then equivalent to doing the mathematical, like the actual matrix multiplication. Maybe it's like, it's not a one-to-one, obviously, right? But I hope you're getting what I'm trying to say. And maybe I'm totally wrong. Maybe that's, apologies, Beth, if that's not what it is. But based off of what I've heard now, I have the feeling that is what it is. That you're building a chip that is able to, and I'm assuming you're able to just program the chip so that it either, you know, does these, or like it does something like these, or and again, imagine it in 3D, right? Like you're able to configure the chip so that it actually models a certain probability distribution with whatever, air pressure, noise, I don't know. I just, this is like, I'm absolutely a noob on all this stuff, right? So this is what I'll love to kind of like dig into this, and let's, what I'm gonna do try to do tomorrow morning European time is like go through and like read these, right? One, like word by word, trying to make sure, and maybe I'll dig into EBMs as well, because that seems like interesting. But essentially that's what it is, man. I think that's what it is. It's not so complicated to understand, right? It's like, of course, I have no idea what it is that it's doing and how it is doing it. And the thing is, I think what's complicated is that operation of how to map the operation of inference and multiplication, how to map that to a physical process that I guess maybe I'm biased because I'm sort of pulling from the stuff that I learned from quantum computing a few years ago, where essentially your quantum state, like if you put all your qubits together, you know, they kind of, it's a similar thing, right? So it's a state that you don't really know what it is until you kind of poke it, right? So you interact with it, and you can measure that interaction and read a collapsed version of it. I'm guessing that's something very similar. And I think if I remember well, I think Beth mentioned something like this in the space, where he says like it's like quantum computing, but it's like not complex numbers, right? It's that distribution, and then you somehow give it an input, it interacts with it, you read these via some sensors, and whatever you're reading out is the result already. The idea is This operation is whatever billions times faster than the matrix multiplication because it just happens naturally, right? It's a natural process that it's just faster, right? Matrix multiplication at the scale that you need to do it now for like machine learning is just it's just very inefficient, right? So why not use nature and sort of at the thermodynamic scales, I would say, why don't use nature to make that operation for you, right? There's a bunch of like kids experiments out there, man. Like they show you like if you isn't there something like water finds labyrinth solution or something like that. There's something like it's not water, but it's like can water solve a maze? Yeah, something like these, right? It's like these where if you and I don't know if you're gonna hear this because I don't know if the sound comes through or not, but like if you the idea is you kind of pour the stuff in here and so it will just naturally find the maze. The question the answer is the question is whether obviously it's like optimal in this case or not, but it's kind of a very naive example of what I think Extropic's chip is doing, right? So a simple example of low complexity distributional learning failing to capture the effect of a tail event. Lower pressure almost always means rain in high drop yields. No, maybe that's not what that's what I thought what it is, but okay, I think this is a bit more the details on how this is implemented. It's fine, I'll read it tomorrow, but I hope that you're getting what I'm hinting at. All what it does at a very high level is the chip is able to create sort of model physically, whatever it is. If it's noise, I just have no idea. It's able to model physically something that you can map to a probability distribution that that is actually what you're trying to model with a neural network, right? Or maybe a part of the neural network, or a neuron, or a layer, whatever it is. You're trying to model that part that you typically have to just write a fucking like long list of just like arrays and or metrics and then do sort of like an actual multiplication. Then you model that in the chip, you interact with it, read the output, and that's just like billions of times faster. This is fucking amazing. If that's something that just works in general, it's great. It's huge because it's like it just removes the limitations of the matrix multiplication, right? So I mean, this has, I guess, way more implications that I'm not even able to kind of grasp at the moment. But I think that's what it is. I hope that makes sense. Let me know. We'll read the whole thing tomorrow. Maybe I'm wrong. Hopefully I'm wrong, because then while reading, we'll just figure out where the actual source of these is and what is it that Extropic is actually building. But I think that's what it is, and that's pretty cool, pretty dope. See you tomorrow in the next session.